In this video, I'm going to teach you about the common transform operations of translate, rotate, and scale. These functions act on objects. Translate will move objects, rotate will twist or turn objects, and scale will grow or shrink objects. You're already familiar with the operands of these functions. The transform component of every object stores a position, rotation, and scale. We'll start by updating the movement code we've been using. Up until now, we've been creating a new position by taking the old position and adding a small amount to it. Now we'll use the translate to update the position. Translate has a few options. The version we're going to be using is going to take an X, Y, and Z and a relative space. For the X and Y, we're going to pass in 0, and then the Z, we're going to pass in our speed times delta time. This will move the object along the world Z axis. The space that we're going to be moving in, there are two options, world and self. The difference between these two is which axis to move the object relative to. The world axis is always the same, but the local axis changes depending on the rotation of the object. Let's visualize these two options within Unity. All objects start with their axes aligned to that of the world axis. So we see when we hit play here, the object will move away from us along the world Z axis. Even if we rotate the object, it's going to move away from us on the world Z axis. So let's look at self translation. Control-Alt-C is the shortcut for toggling comments. It's very useful. Here we're going to be doing the same thing, translating along the Z axis, except the space is going to be self. This is a local space transform. So here we'll see the object will move along the Z axis, its own Z axis, which in this case happens to be the same as the world Z axis. However, when we rotate it, the object is now going to move along its own Z axis, which does not align with the world Z axis. So why is this useful? Well, let's call the local Z axis of the object forward. Now, whenever we want to move the object forward, without needing to do any additional calculations, we can just translate it along its local Z axis, and the object moves forward. Now let's look at rotating an object. Unity stores rotations as quaternions. The details of quaternions are beyond the scope of this course, but Unity abstracts away most of the details anyway. There are a few different ways to apply rotations, because rotation data can be viewed in different ways. The way Unity displays rotation in the inspector is with Euler angles. Euler angles have an X, Y, and Z component. That means when the object is rotated, it's rotated Z degrees around the Z axis, X